everybody, my name is Addie Clear and I'm representing Group 4 along with Jake, Philip, and Clark, and here's our planning report. The first task we completed was developing our house of quality, which combines the engineering and customer requirements and looks at the relationship between each. The engineering requirements we identified as most important included simplicity and proximity sensor. The proximity sensor is used multiple times throughout the competition. For example, it identifies when to release the red pills into the red zone. Simplicity ensures consistent task completion by allowing us to have easy maintenance and a quick setup time. Important customer requirements include safety and consistent task completion as well. After developing our house of quality, we made a specification sheet, which expands upon the engineering requirements. A lot of these specifications are listed as demands, as they are obtained from the competition guidelines. For example, for geometry, the machine must fit within a 12 by 24 by 18-inch box. The most difficult specifications to meet, we believe, will be the time constraints, as the machine must be set up within 2 minutes and 45 seconds before the machine can be released.
As for our function tree, the overall goal was pretty simple. Complete all the competition tasks and hopefully score more points than the other teams while doing so. That can be broken up into the 4 basic ways of scoring points: defeating the sentinels, moving the dog bone out of your zone, gathering programming modules, bringing the tennis balls into your zone, placing the pills, putting the ping pong balls into the red zone, and retrieving Morpheus. We used subfunctions from this function tree to create a morph chart that gave us a few solutions to those problems. So far, we've only made it to the programming modules, which we decided to use mouse traps, actuators, and a DC motor for, but we will expand on this chart as we go into some of the other subfunction tests.
The next tool we created was a planning tree diagram, which decomposes our broad task into 4 smaller tasks, which are understanding the competition problem, developing design concepts, creating a prototype, and creating reports and presentations. It further decomposes the 4 categories into tasks that are completable by an individual, such as creating a house of quality. We then created a Gantt chart, which assigns the tasks from the planning tree to a schedule. As you can see on the Gantt chart, we are currently working on the programming modules subsystem this week. The Gantt chart outlines our tasks from the planning tree and assigns them in a way that we can stick to a schedule and deliver our subsystems on time.
Next, we created a prioritization matrix, which takes the various tasks from the Gantt chart and shows how we value them in respect to one another, such as here you can see that understanding the problem we prioritize above all, seeing as how it is foundational to completing the project. You can also see that assembly and testing of the program module system is valued higher than the others, seeing as how that is how we plan to score most of our points. And here we have a job matrix, which takes the various tasks we will need to complete in doing this project and breaks them down based on who will be primarily responsible for doing these based on our strengths. So our next steps are to create the pill and Morpheus subsystems and to combine all of our subsystems into one cohesive machine, to further develop our strategy for the competition, to complete the report, to win the competition, and to stay safe.